So here's a little bit of help on Unit 2, Section 2, Statistics. We're going to revisit statistics a little bit later in Unit 4, but this section of Unit 2 is designed to give you a little bit of help when we're talking about the very simple type of statistics we use when we're trying to look at quality control values. So you get a little bit of this in Gary's clinical chemistry class, and I thought it might be a good idea to hit it on it a little bit right here. So the idea behind everything that we're doing here, let's say, and I'm going to keep this real simple, let's say that there's a certain test that we run, and we've got a quality control that has a value of 2. I know it's pretty simple, but go with it. So the idea is that if 1,000 people ran this control, I would expect to find a value of 2 over and over again. So we would say that the average, or what the average person is getting, would be equal to 2. But the idea is we're going to have a couple people that'll get a 1, maybe a couple people that get 3. We might get some bozos who get a 0, and then some guys who are, off in La La Land getting values of 4. And then maybe some dude who comes in and gets 12. The idea is we need some sort of mathematical way to say which values are acceptable and which are not. So that's where these statistics come in. So let's pretend that we do have this control value that we're running, and we had 6 people run it in our lab. And we got a 1, a 2, a 3, a 1, a 2, and a 3, just to keep things simple. Well, if I want to find the average, I can. So I add up all these numbers. So the sum divided by each individual data point, or what we consider the n, or the number of data points that I have. So sum divided by n, or my sum divided by all the numbers that I have. And if I do it for this guy, 1 plus 2 is 3, plus 3 is 6, plus 1 is 7, plus 2 is 9, plus 3 is 12. I've got 6 values, so my average would be 2, which is good. That's what I want. That's what my control value is. But now I need to start to see if these guys getting 1s and these guys getting 3s would be within what we call acceptable limits. So that's when this whole idea of standard deviations comes in. So what is the standard deviation of these numbers? What we're essentially talking about is how far does the average number deviate or stray from this mean. You hear the example a lot, hey, how far does the average person live from their elementary school? You can kind of look at that as a standard deviation. So the average distance away from the center point. That's what we're looking for with these numbers. The problem is it's not so simple as just finding a number. We have to use a mathematical equation. So the equation is kind of ugly, but it's not that hard. So the equation is my standard deviation is equal to the square root of the sum of each data point, so that's what the XD is, so each individual number minus the mean, and then we're going to square that number. A lot of times that's to get rid of any negatives. And then we take that whole number there and we divide it by what's called the degrees of freedom, or our n minus 1. So really this is pretty easy. What I'm going to do is I can set up a little chart where I've got my number, I've got my mean, I have the number minus the mean, which is what's represented right there in my equation, and then I have the number minus the mean squared, because it's the sum of those values that I'm looking for. So for this example, I've got 1, 2, 3, 4, 5, 6 data points. My numbers are 1, 2, 3, 1, 2, 3. My mean is 2. It's going to be 2 for all of these guys. So the number minus the mean, 1 minus 2 is negative 1, 2 minus 2 is 0, 3 minus 2 is 1, and again. So there's my difference, or my XD minus my X. I square those values and get 1, 0, 1, 1, 0, 1. Now my equations ask me for the sum of those squared differences. And so I just sum up this column, which is the differences squared. So 1 plus 1 plus 1 plus 1, I get a value of 4. So my standard deviation is equal to the square root of 4 divided by my degrees of freedom, which is 6 minus 1. And so when I figure that guy out, I have the square root of 4 over 5. And I can just pop that in my calculator. I do square root of parentheses 4 divided by 5. And I get 0.894. And that would be 1 standard deviation. So what that is telling me is that if I have this set of numbers, 1, 2, 3, 1, 2, 3, the average number is going to be about 0.894 away from the mean. We use that in the lab to determine what level of quality control that we will accept.